Hello Year 10s, I hope you're all well and working hard. Thankfully you're nearly at the end of your home learning spell, so you'll be back with us soon. Very much looking forward to seeing you all again. So for today we're going to be looking at P6, which is Molecules and Matter, Lesson 1. How can we calculate the density of an object? Before we start, please just make sure your phone is off or not with you so you're not distracted by it. Any other tabs you have on your computer, if you're watching on your computer, are closed, and that you have your booklet in front of you so you can follow along with it as well. If you do have any questions, please do contact me. So first off, we're going to be looking at just doing a bit of maths and some calculations. So you needed to match up the shape to the formula for finding the area. So we've got a triangle, a circle, and a square or a rectangle. And then we've got the formula for finding the area, which is either base times height, base times the perpendicular height divided by 2, or pi times the radius squared. There is a challenge there as well to find the areas of those shapes. If you do that, please send me a message on Share My Homework saying what areas you found for each one. So hopefully you will have done the starter. If not, please pause the video so you can go through it and I'll show you the answers. So welcome back. Let's have a look at the answers. So for a triangle, correct area was the base times the perpendicular height divided by 2. I remember it as half base times height, but however you want to remember it is fine. For our circle, our answer is pi times the radius squared, or pi r squared. And for our square or rectangle, we do the base times the height, so one side times the other. So moving on then, we're going to have a look at what density is. So density is just a measure of how heavy a certain object is, or a certain volume of an object is. That's the number of particles in a certain space. The more particles there are, the more dense it is, the heavier it will be. You know a lot about density already just from things that you see. You know that if you put a stone into some water, the stone will sink because the stone is more dense than the water. If you put a bit of wood on some water, the wood will float because the wood is less dense than the water. We'll look a bit more about why different shapes will affect the density in a bit later on and in our next lesson, so tomorrow. So we have a formula, a nice big formula for you to learn, and that is density equals our mass divided by our volume. So density equals mass divided by volume. And for mass, we can either measure it in kilograms or in grams. So we either measure mass in kilograms or grams, depending on how big it is. Our volume, we're going to measure it in meters cubed or in centimeters cubed. This is how we calculate volume, either in meters cubed or centimeters cubed. And therefore, for our density, we can have two different units for it. We can either have it as kilograms per meter cubed, so how many kilograms we have of something per meter cubed, or we can have it, okay, I won't do the orbit there, or we can have it as grams per centimeter cubed. Apologies for this bit sitting up there, not really sure why that's happened. But we can have kilograms per meter cubed, or we can have grams per centimeter cubed. And that we get that by dividing the mass by the volume. And we do have it, we can write it as a shorthand as well. We have it at the bottom there. We have that funny P-shaped thing. That is the Greek letter rho, equals m divided by v. So mass divided by volume. We'll come on to why we use the Greek letter rho. So we're now going to have a look at doing an example. So this is the same example in your workbook, so you can follow it along in there. We've got a wooden cube, has lengths 8 centimeters, and it has a mass of 307.2 grams. Find the density of the cube. So to do this, we need to use our equation. So we have our density equals our mass divided by our volume. We've already got the mass. It is here. So I've got that one. I've not got my volume yet. I need to work out my volume. Now I've got a cube, so it means that all the lengths are the same size. They're all going to be 8 centimeters. So to find the volume of the cube, I'm going to do the height times the depth times the width times the depth. So we have a cube. I will try and draw one. So we have a cube. All of these sides are 8 centimeters. I know it's a terrible cube. It's not very cube-like. But each one is 8 centimeters. So I'll do this times by this, and I'll need to times it by my depth as well to get the answer. So it'll be 8 times 8 times 8. So that will give me my density will equal my mass, which was 307.2 grams, divided by my volume, which is going to be 8 times 8 times 8. And I'm going to use a calculator for this. I can't do this in my head. These sums are too hard. Again, we let you use calculators in science. So my density will equal 307.2 grams divided by 8 times 8 times 8, which gives me 512. It's centimeters, and it's cubed because it's a volume. If I then do this on my calculator, I will find my density is 0.6 grams per centimeter cubed. This is my answer. I've done 307.2 divided by 512, and I've got 0.6 grams per centimeter cubed. Just using this equation. That's all I'm having to do for it. You'll be doing a bit more of this in the questions later on. Just use the equation. You might need to rearrange it and make either mass or volume the subject, but I know you can all do that absolutely fine. So we're now going to look at changing densities. So if we make an object warmer, so if we heat it up, the density will decrease because we've got less particles per unit volume, so less particles in the volume. That's because as we heat them up, they have more kinetic energy. They're moving faster, so in a solid they're vibrating more. A solid will expand if it gets heated up, so it will take up more room, but the mass of it hasn't changed. So if the mass has stayed the same and the volume has increased, the density will decrease. Likewise, if we cool it down, we get more particles per unit volume, so the density will increase. I've got two examples there. Same size box, but because on the one in the right we have increased the temperature, we now have less particles in there. On the left we have decreased the temperature, we've got more particles in there. It's going to have a greater mass per unit volume, so it becomes more dense. We can also do it by changing state. So if we change state, so going from a solid to a liquid to a gas, the density will change as well. Again, it's because of the number of particles we have per volume. A solid, we've got them all in a fixed shape. Generally, our solid will have the highest density. A liquid will have a slightly lower density, and a gas will have the smallest density. Most of the time, solids have the highest density when it's a material, apart from water. So water, when it freezes and becomes ice, actually becomes less dense than liquid water. You can see this. Obviously, you can see ice floating on drinks, icebergs floating on the sea. We know it and we accept it, but actually, it is a little bit weird. We do look at this more, especially if you go on to look at A-level science. We look at it all and realise how weird water is, but that is definitely something you should look into doing. But for now, just concentrate on the densities, follow that through. Have a go at answering the questions in the book. You can contact me if you have any questions, either on Show My Homework or via email, and I will see you all in our Microsoft Teams session tomorrow. Have a great day. Again, any questions, please contact me. Thank you very much. Bye-bye.